Now in the last part of the question we're told that R is a force then that acts on a particle, let's just put the particle here, of mass m, and the magnitude of the acceleration, let's just say the acceleration is in the direction of the force R. We're told that the magnitude, the size of it, is 8√5 meters per second per second. So we've got our particle then accelerating in this direction with a magnitude of 8√5 meters per second. And we're also told that Q equals 1 and asked to find the mass m. So how do we do this? Well, first of all, if Q is 1, we know that from the earlier part of the question that 2p plus Q plus 3 equals 0. So I can substitute Q equals 1 into this equation. Now I've kept the equations that we've already got from the previous parts. Let's number this one 1, that was the force R, and we'll number this one 2. Okay, and so if Q equals 1, we'll just sub this into equation 2, and what we've got is that 2p plus Q, which we know is 1, so we've got 1 and 3, which is 4, equals 0. And if you rearrange this for p, you get 2p equals minus 4, divide by 2, and it follows that p equals minus 2. Okay, now that we've got p is minus 2, what we can do is substitute that with p, with p and q, we can substitute those values back up into number 1 and get the force R. So if we do that, we can say that therefore R as a vector equals 4 plus p in the I direction. Well, p is minus 2, so 4 minus 2 is 2, so we've got 2i, and as for the j components, we've got q minus 5, q is 1, so we've got 1 minus 5, which is negative 4j. So that's our force R. Now we know that force equals mass times acceleration, and so if we find the magnitude of R, we know that the magnitude of R must equal the mass times the magnitude of the acceleration. Well, we've already got the magnitude of the acceleration, it's 8√5. What we need to get is the magnitude of R. So we can do that from here. We can find out the magnitude of R just by using Pythagoras' theorem. The components are 2 minus 4, that's 2 units across for 4 down. So by using Pythagoras' theorem, it's going to be the square root then of 2 squared plus 4 squared. So 2 squared is 4, 4 squared is 16, that's in other words the square root of 20. And the square root of 20 can be broken down to the square root of 4 times 5, which is 2√5. So the magnitude of R is 2√5 newtons. So using this result, that the magnitude of R equals the mass times the magnitude of A, we therefore have 2√5 equals m times the magnitude of A, which is 8√5. So to get m, all I've got to do is divide 2√5 by 8√5. The root 5's cancel, you're left with 2 over 8, 2/8, which is in fact a quarter. So m equals a quarter. Okay, so that brings us now to the end of the whole of this question.